let's go to page 672, and this is lesson 10.4. This lesson is to use inscribed angles and polygons. Okay, so over here it says an inscribed angle, so this angle right over here, so that's an inscribed angle. So this is your inscribed angle right over here. It says an inscribed angle is an angle whose vertex, so vertex is on a circle and whose sides contain the chords of the circle. Okay, so this is intercepted angle. It says the arc that lies in the interior of the inscribed angle and has endpoints on the angle is called the intercepted arc. So this is intercepted arc. So intercepted arc basically is the inscribed angle intersect with a circle. So again, this is the inscribed angle right over here, and this is the intercepted arc. Okay, now let's go to theorem 10.7. Theorem 10.7 says measure of an inscribed angle theorem. So it says the measure of an inscribed angle is 1/2 the measure of the intercepted arc. So what it says is that this angle is half of the measure of the arc. Okay, so again, the angle is half of the arc. Okay. And it doesn't matter which case it is. Notice there are 3 cases, right? Case 1 is the center is on a side of the inscribed angle. Case 2 is when it's inside the angle. Case 3 is outside the angle. But it doesn't matter what case it is. The angle is always half of the arc. Okay, the angle is half the arc. The angle is half of the arc. Okay, now let's go and do example 1. It says find the indicated measure in circle P. So here's your circle, and this P is right over here, the center. So that's why it's called the center circle P. So measure angle T right over here. Again, remember the angle is half of the arc. So if this is 48, this would be 24. Okay, and you're looking for measure of arc QR right over here. Okay. Okay. Now this is a little bit harder, but it's not too bad. Okay. So if you notice, this is 50 degrees, right? So that means this arc is 100 degrees. Okay. So again, this is 50. So this is 100. Okay. Now, if you notice that this is the diameter. Okay. Notice it goes to the center. Okay. So this is the TR is the diameter. So if this is the diameter, that means this is half of the circle. So TQR is half of the circle. So therefore TQR is 180. So that means this has to be 80 degrees. Okay. So again, because one circle is 360, so this is 360. So half of the circle is 180. So this is 50. So this has to be 100, and therefore this has to be 80 to make into 180. Okay. So you have to know all these theorems. Okay. Okay. Now, let's go to page 673. Okay, so it says one measure of the arc RS. Okay, so that one's very easy because this is 31 and this would be double, so this would be 62 degrees. Okay. And now it says, what did you notice about angle STR? So it's right over here, STR and RUS. Well, if you notice that, okay, so this arc, this arc is had to be twice as that, right? But notice this angle has the same arc. So this would be 31 degrees because this would be half of that. Okay? So what you notice is that this angle are congruent. Okay? And that brings to the theorem 10.8. So 10.8 says, if 2 inscribed angles of a circle intercept the same arc, the angles are congruent. Okay, so notice this angle has an arc AB, the angle C has an arc AB, therefore they are congruent. Okay, so again, if the 2 angles have the same arc, intercept the same arc, they are congruent. Okay, and vice versa. If 2 angles are congruent, the angle that intercept, the arc that intercept will be the same, right? Okay. So that goes to example 3. So name 2 pairs of congruent angles in the figure. Okay, and again, you just go to each one, and the correct answer will be C, because over here You got JKM, that is this angle right over here. Okay? It's congruent to JLM over here. Right? I'm going to use the marking. Okay, these two angles are congruent because it intercepts JM. See that? Okay? And same way, KJL, so KJL, that's this angle right over here, is congruent to KML, this one here, because both of them intersect the KL arc. Okay? So again, two angles are congruent if they intercept the same arc. Okay, let's go to next one. Let's go to page 674. Okay, it says polygons. Okay, a polygon is an inscribed polygon if all its vertices lies on a circle. So like this one, this is an inscribed triangle because all three vertices of a triangle are on the circle. So this is an inscribed triangle. This is inscribed quadrilateral because all four vertices are on the circle. Okay. So again, the one that on the inside is called inscribed. Whatever is inside is inscribed. So if it's quadrilateral, it's inscribed quadrilateral. If it's triangle, it's inscribed triangle. The one on the outside is circumscribed. Okay. So the circle is on the outside, so the circle is called circumscribed circles. Okay. So again, the one on the outside is circum. The one on the inside is inscribed. Okay, let's go to theorem 10.9. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Okay, so again, if it's a right triangle is in a circle, then the hypotenuse would be the diameter. The reason for that is because, remember, the angle is half of the inscribed arc, right? So if this is the diameter, this is half of the circle, right? So again, if this is diameter, this will be half of the circle, so this will be 180 degrees, right? And if this is 180, then this is the inscribed angle, so this will be half of that, so this will be 90 degrees, okay? So again, if this is a diameter, then this is 180, and therefore this would be a 90, therefore this would be a right angle. So if you notice that kind of go to this application, okay? Use a circumscribed circle. Photography. It says your camera has a 90-degree field of vision, and you want to photograph the front of a statue. You move to a spot where the statue is the only thing captured in your picture, as shown. You want to change your position. Where else can you stand so that statue is perfectly framed in this way? The answer is that if you make this like a diameter of the circle, like right over here. See, if this is a diameter of a circle, so that means this would be 180. So no matter where you stand on the circle, it's always 90 degrees. So if you're over here, notice that this would be 90 degrees. If you're over here, 90 degrees. So any point on the circle, okay, will form a 90-degree angle. Okay. So again, that's kind of useful to know how to use the diameter as a part of the inscribed triangle. Okay. Okay. Now another useful theorem, okay, is on theorem 10.10. Okay, inscribed quadrilateral. Only certain quadrilateral can be inscribed in a circle. Okay, theorem 10.10 describe this quadrilateral. Theorem 10.10. It says a quadrilateral can be inscribed in a circle if, now notice it says if and only if, right? That means it's true both ways, okay? So quadrilateral inscribed, then the opposite angles are supplementary, okay? The reason for that is because this angle D is intercept this much arc, okay? This angle F is intercept this much arc. Notice angle D and angle F intercept the entire circle, okay? And therefore, angle D and angle F have to be half of the circle, so be 180, okay? And same thing. So if you do the same thing with angle E and G, okay? So if you notice angle E this angle over here intercept this arc right over here, and angle G intercept this arc right over here. So notice these two opposite angles intercept entire circle. Therefore, these two angles have to add up equal to 180. Because remember, the angle is half of the intercepted arc, right? Okay. So again, if the two angles intercept entire circle, that means the two angles have to equal to 180. Okay, half the entire circle is, the entire circle is 360, right? So half of that is 180. Okay, so now you can go and use that to solve some problems. Okay. So it says find the value of each variable. Okay. So over here, if this is 75, remember opposite angles are 180, right? So if this is 75, this would be 180 minus 75 will give you 105. Okay. So 180 minus 75 give you 105. This one again, the opposite angle is 180, so 180 minus 80, x will give you 100. Okay. Now this one over here, to find the value of each variable again. So now this one, you can solve for A, okay, and solve for B by, so opposite angle equal to 180, okay? So 4B plus 2B equal to 6B, so 6B equal to 180, so B equal to 30, okay, over here. So again, measure angle K plus measure angle B equal to 180. Opposite angles are supplementary equal to 180. So substitute 4B plus 2B equal to 180. So this will equal to 6B equal to 180. So B equal to 30. So same thing with A, right? Opposite angles are supplementary. Okay, again, opposite angle is equal to 180. So 2A plus 2A equal to 180. So this will give you 4A equal to 180. So A equal to 45. Okay.